Okay, in this video, we're going to walk through the first homework problem, and you can see that I have a circuit here with a 10-volt battery and 1, 2, 3, 4 resistors. So I'm first going to find my equivalent resistance, and I'm starting as far away from the battery as possible. So I'm going to keep my battery of 10 volts, my 20 ohm resistor, which notice they called it R1, and another 20 ohm resistor, they called it R4, and I'm going to combine resistor 2 and 3. So I did here 1 divided by 30 plus 1 divided by 50, flipped over the answer, and we have an REQ of 18.75. So let's put that in here, REQ of 18.75. All right, and then looking at these resistors, these are all in series, so we can combine them all at the same time. So I'm going to leave a little bit of room to calculate in between here. So I'll put my battery back in, that's 10 volts. And we will replace all 3 of those with an REQ of 58.75. So REQ 58.75. All right, next thing we'll do is we will apply Veer, Ohm's law. And that would be 10. I'm solving for the current coming out of the battery, 58.75. And the current coming out of the battery then is going to be 0.17 amps. We'll then take that current and we'll put it back into the power equation. And so the current is 0.17 times our 10 volt battery. It's going to give me 1.7 watts. All right, so let's, in this extra space up here, let's make our circuit chart. And we have 4 resistors. So I'm going to make sure that I have 4 rows in my circuit chart. That's a P. All right, so here's 1, 2, 3, and 4. So we'll go down. All right, so we have a 20 ohm resistor. We have another 20 ohm resistor, so I just kind of have to keep track of them. So I'm going to also call this one R1 and this one R4 as they're labeled in the picture. And then we also have a 30 and a 50. And the power is supposed to add up to 1.7 watts. So notice that the power number is a small value, 1.7. That's just a clue that I'm going to have to kind of keep more decimal places than normal if I want to get my answer to be close to 1.7. Okay, so we're ready to start the calculate and carry back method. So I took my first picture and I calculated, and I'm going to carry back that answer then to the previous picture. And I'm going to kind of talk to myself. So we learned that the current coming out of the battery is 0.17 amps. So that's the rate that the electrons are coming out of the battery. So 0.17 amps goes through the first 20, which is R1. So this is going to be 0.17 amps. And then it's going to go over here, and 0.17 amps is going to go through the REQ. Because it's an REQ, that's where I'm going to have to do my Ohm's law, but I'm going to come back to that for a second. And then the current's going to keep on going through here, and that full 0.17 amps is also going to go through the second 20 ohm resistor. So we're going to write in a 0.17 there. But we got to figure out what's going on over here. So we were marching along with a current of 0.17 amps, and we hit an REQ of 18.75. So it looks like we're going to be calculating a voltage. So that is going to turn out to be 3.19 volts. So 3.19 volts. All right, so I calculated, and then I'm going to carry back that answer to whatever made up the REQ, which is over here. And you might remember from our notes the other day that voltages in parallel lines is the same. So when the electrons come out of this battery here, we calculated how many volts or sticks of dynamite it would take for it to cross this 30 ohm resistor. So it's going to take 3.19 to go through the 30. So we can write that in our chart. 3.19. And it's also going to take 3.19 volts to go across the 50. So we could put that in our chart. All right, so we have two things in every row. And if you have two things in every row, we should be able to go through and calculate the other missing values. So I'm going to switch now, pens, and we're going to do that. So 20 times 0.17, that's going to give me a 3.4, and that's going to be the same value, times 0.17. So the power is going to be 0.578. So here's an example of when I'm going to keep an extra decimal place there. All right, then I have 3.19, and I'll divide by the resistance so I can get the current. So that's going to be I'll say 106 times 3.19, and that's going to be 0.339 watts. 3.19 divided by a resistance of 50 will give me a current of 0.0638 times 3.19, and that gives me 0.20. I'll call it a 4, but we'll see what that does for us. Okay, so plus, let's add these all up now and see how close we are to the answer that we would expect. And we get 1.69 rounded off, 1.7 watts. That's like a perfect fit. Beautiful, beautiful. Okay, so we know we're correct. So let's buzz through our answers very quickly. So calculate the equivalent resistance. We did. So that's going to be 58.75 ohms. Current coming from the battery was 0.17 amps. The power spent by the external circuit would be 1.7 watts. The current passing through R1, is 0.17 amps. The power by R2 is the 30, the power of the 30 is 0.339 watts. The voltage drop across R3, so the voltage drop of the 50 is 3.19 volts. The rate at which energy is lost, which again we talked about is another word for power. So the power of R4, the power of this 20 right there, 0.578 watts. We're going to cross off this question. And the last thing that we have to talk about then is placing the meters in the proper location. All right, so suppose we wanted to measure the current passing through R4. The current passing through R4. So the current anywhere in this line from this junction all the way through to the battery is going to be the same. So I could put my ammeter here or here or here. I'm just going to pick this spot right here. And so I just draw an A there. And then letter J, suppose you wanted to measure the voltage drop across R4. So I would have to take my voltmeter and I could put it either inside or I actually could draw it outside like this. But no matter where you put it, you would take his little extra wires and you would attach one of the wires before the resistor and one of them after so that you would be measuring the voltage drop. All right, so I hope you had a chance to try the homework problem yourself and then can kind of use this as a check to see if you made it through correctly or if you made a mistake, maybe you'll be able to find your mistake there. Later on, I will make a quick video of the last two problems.